This lecture is for Math 1508 Pre-Calculus at UTEP. Chapter 1, Functions and their Graphs, Section 1.3, Linear Equations in Two Variables. This goes along with Larson's Pre-Calculus, 10th edition, the text we'll use in class. Alright, so what's a linear equation? A linear equation is the simplest mathematical model for relating two variables. Generally, it'll be of the form y equals mx plus b. We call this the slope-intercept form of a line. The m represents the slope or the tilt of the line, and the b represents the y-intercept of the line. We've talked about intercepts. That tells us that at this value b, the graph of this line crosses the y-axis. Now a little bit more about the slope. The slope m of a line through two generic points is given by this formula, m equals y2 minus y1 over x2 minus x1. As long as our x1 and x2 are different, can't have the same value or else we have a 0 in the denominator. Remember, it's always the change in y over the change in x. What comes first alphabetically? X does, before y. Denominator comes before numerator. Slope, rise over run. So rise is a vertical change, run is a horizontal change. Horizontal comes before vertical alphabetically, denominator comes before numerator alphabetically, x comes before y alphabetically. Make sure your x's are in the denominator, your y's are in the numerator, and you subtract in the same order. The order does matter here. So if we use a generic point xy along with a specific point x1, y1, and we use the slope formula, m equals y minus y1 over x minus x1. Here xy is our generic point. x1, y1 is our specific point. We can manipulate it to find another version of a linear equation. So if I'm looking here, m equals y minus y1 over x minus x1, I'm going to multiply both sides by this denominator. X minus x1 will cancel out on the right side. These two cancel out. When I multiply on the left, I end up with just m times x minus x1. On the right, I end up with y minus y1. And this is fine. This is perfectly acceptable. But we know it more frequently with the two sides switched. So y minus y1 equals m times x minus x1. This is called the point-slope form of a line. If you have a slope m and a known point x1, y1 with the generic x and y, we can find the equation of a line as well. So let's look at some examples. Well, there's not a lot of examples here, and that's why you show up to class, is so you could get more examples. But let's give some basic ones to start. Make sure you understand the concept, at least in the most basic form. Find the slope and y-intercept of the line through the given pair of points. Then write the equation of the line in slope-intercept form. So the first thing I'm going to do is find my slope. The slope formula said y2, negative 8, minus y1, 0, over x2, 0, minus x1, which is 12. Since I started the numerator subtraction with negative 8, I have to start the denominator subtraction with 0, so I make sure I keep my order of subtraction of the points correct. Now negative 8 minus 0 is negative 8, and 0 minus 12 is negative 12. Here I've shown you, factoring a negative 4 out of both the numerator and denominator, how we can simplify a fraction. Negative 8 over negative 12 is the same as a positive 2/3. In this particular problem, our y-intercept was given to us. 0, negative 8. Anytime the x value is 0, this is a y-intercept given to us, 0, negative 8, and so I can write the equation of the line. Y equals m, 2/3, x minus 8. So mx plus b. In this case, my b is negative, so I'll use mx minus 8. Same thing. Now we're given two different points, 2, 4, and 4, negative 4. First step, still going to be find the slope. So I take negative 4 and I subtract 4 in the numerator. And then I start with the second point again. I take my 4 and subtract 2, my x values in the denominator. Negative 4 minus 4 is negative 8. 4 minus 2 is 2. Negative 8 over 2 is negative 4. This is my slope. Unfortunately, the y-intercept is not given, and if it's not given, we have to find it. We're going to use the point-slope form in order to get that done. What does the point-slope form need? It needs a point, and it needs a slope. I have 2 points that I can choose from. When I'm given the choice, I'm going to take the easier one. And for me, the 0.24 is easier than the 0.4 negative 4 because the 0.24 doesn't have any negative signs in it. So anything without a negative sign, anything with a 0, choose whichever one you want. It's still going to be all right. So we have y minus our y value of the given point equals m, the slope value we found, times x minus the specific x value 2. So we have 2 goes here, my 4 here, and my slope negative 4 in my formula y minus y1 equals m times x minus x1. Alright, so what do we do with this? First step, we're going to distribute. Negative 4 multiplied by x is negative 4x. Negative 4 multiplied by negative 2 is positive 8. Here I have an equation. I want to get y by itself. I'm going to add 4 to both sides. Y equals negative 4x plus 12. I found my equation, and now once I have the equation, I know exactly what my y-intercept is. It's the b value. It's 12. It's a y-intercept, so the x value must be 0. All right, let's do one more. Negative 2 comma 1 and negative 4, negative 5. First step, find the slope. Negative 5 minus 1 over negative 4 minus a negative 2. Negative 5 minus 1 is negative 6. Negative 4 plus 2 is negative 2. And negative 6 over negative 2 is 3. We have our slope. I could choose either one of these 2 points. I chose the point negative 2, 1. So y minus my y value of 1 equals m, 3, times x minus my x value of negative 2. In my first step, I changed subtracting a negative to addition. In my second step, I distributed 3 times x and 3 times 2. I left the left-hand side of the equation alone. If I have y minus 1 equals 3x plus 6, I'm going to add 1 to both sides and find my equation. Y equals 3x plus 7, and that gives me a y-intercept of 0, 7. Alright, so now we're given a slope and we're given a point, and we want to find 3 other points through which the line passes. Well, what does a slope mean? A slope is the tilt of the line. So a slope of negative 1 means what? It means we could write it as a fraction, negative 1 over positive 1. And remember, the numerator is vertical. It's the rise. And the negative tells me I'm going to go down 1. And the denominator, that's the run, that's the horizontal. It's positive, so I'm going to go to the right 1. So if my slope is negative 1, I think of it as down 1 and right 1. So if I start at the point 3, negative 2, my y values, I subtract 1. My x values, I add 1. Right? Negative 1 for the y values, positive 1 to the x values. From 4, negative 3, I'm going to add 1 to the x. I'm going to subtract 1 from y. From 5, negative 4, I add 1 to x. I subtract 1 from y. Now keep in mind that negative 1 could be written as 1, negative 1, in which case we'd go up 1 and left 1. And that's okay. We could do that. The only difference would be here. Instead of 3, I would go down 1 in x, and I would go up 1 in y. Down 1 in x, up 1 in y. And I can find 3 points that way as well. So where you choose to put the negative, whether it's in the numerator or in the denominator, as long as your fraction simplifies to the correct slope, you're good to go. It doesn't matter. Let's try it again. When the slope is 2, 2 is the same as 2 over 1. So I'm going to go up 2, or add 2 to y. I'm going to go right 1, which is adding 1 to x. You could also use a double negative. So starting with the point negative 5, 4 is given to us. I'm going to add 1 to x, add 2 to y. I have negative 4, 6. Add 1 to x, add 2 to y. add 1 to x, add 2 to y. Similarly, we could go left 1, so that takes us to a -6. And down 2, so from 4, I'll go down 2 and get it 2. Down 1 with x, down 2 with y. And I can go in that direction as well. Alright, throw a couple of facts at you here. Slopes can be used to determine if two non-vertical lines in a plane are parallel or perpendicular. Now we say non-vertical because vertical lines have the same x value. And if they have the same x value, the denominator in the slope formula would be 0, and so we can't talk about a slope. So we have to say non-vertical lines. So two distinct non-vertical lines are parallel if and only if their slopes are equal. That's it. If the slopes are equal, the lines are parallel. Two non-vertical lines are perpendicular if and only if, there should be a D on here, if and only if their slopes are negative reciprocals of each other. That is, m1 equals a -1 over m2. Another way we might say this is that two lines are perpendicular, two non-vertical lines are perpendicular if their product equals -1. And depending on the textbook, some people define it as I have written, while others define it as I have it typed. Either way, it's the same thing. Alright, let's get some word problem examples here. And we'll do way more of these in class, don't worry. So you're driving on a road that has a 6% uphill grade. This means that the slope of the road is 6 over 100, right? Percent is out of 100. Approximate the amount of vertical change in your position if you drive 200 feet. So, I know that slope is change in y over change in x. I know the change in y is 6, and the change in x is 100. 6 is the vertical change, 100 is the horizontal change. If I drive 200 feet, my change in height would be 12. How does 100 become 200? We multiply by 2. 6 times 2 would give us an answer of 12. Alright, a microchip manufacturer pays its assembly line workers $12.25 per hour, so that's probably important. In addition, workers receive a piecework rate of 75 cents per unit produced. Alright, write a linear equation, and that's very important, write a linear equation for the hourly wage W in terms of the number of units X produced per hour. Now the same exact problem, only I have color-coded our information. The $12.25 per hour is a guaranteed wage. So that's a fixed cost. That's our y-intercept. But depending on how many units they produce, the 75 cents per unit, the 75 cents is multiplied by x because x is the number of units produced per hour. 75 cents for every unit they produce on top of their $12.25 per hour. The problem asks us to name this particular function w. X was told to be our variable, and this is the wage that this particular worker could make per hour in this job. What about commissions? A pharmaceutical salesperson receives a monthly salary of $2,500 plus a commission of 7% of sales. Write a linear equation for the salesperson's monthly wage W, so they tell us how to name it, in terms of, so using the variable monthly sales S. A pharmaceutical salesperson receives a monthly salary of $2,500, guaranteed $2,500 a month. Plus, so I'm going to add, a commission of 7% of sales. If sales is given by the capital S, our variable has to be a capital S, 7% in decimal form, 0.07, times the amount of sales plus the $2,500 base salary will be our linear function. Call it W, use a capital S as your variable. Watch for this on WebAssign. You're going to get it right, and you're going to ask me why it was counted wrong, and I'm going to tell you capital S. That's it. Pay attention to case when it comes to WebAssign. That's the end of this lecture. We'll do more examples in class.